Hello, and welcome to PlayFab Multiplayer's Hosted Servers Part 2, Foundations for Scaling Game Server Resources. I'm Lester Jackson, Senior Program Manager of the Multiplayer Servers product.
Welcome back. I'm Dimitri Garnatsios, and I'm a software engineer on the same team.
In Part 2 of this session, we'll build off the game servers we deployed in Part 1. This session is intended for game developers with an operating game successfully deployed in PlayFab, but needing cost-efficient solutions to automatically maintain game server availability based on player demand, as well as control defining the elasticity of resource scaling. Some common use cases include a game launch with unpredicted player demand or a scheduled launch with predicted player demand. If you've never deployed a game server in PlayFab, I recommend you run through the first session of the GameStack Live presentation. After completing this session, you will learn advanced scaling techniques that adjust game server hosting capacity to meet dynamic shifts in player demand. The controls illustrated will help developers efficiently keep game server hosting costs low while maintaining enough capacity to add new players with minimal to no waiting. PlayFab scaling capabilities enable developers to adjust game server hosting capacity to meet actual player demand. These controls help developers efficiently keep game server hosting costs low while maintaining enough capacity to quickly add new players to join multiplayer games with minimal to no waiting. A summary of the scaling benefits include increasing application availability. That ensures that your game server pool always has the right amount of VMs by proactively provisioning capacity. Another benefit is lowering compute costs, where the platform adds instances only when needed to optimize costs. And a final benefit is scaling instances across purchase options, where you can scale options that optimize performance across instance type, region, size, and game server build configurations. There are multiple methods to scale your multiplayer servers in and out. PlayFab offers multiple mechanisms to scale when and how to scale your servers. As the game developer, you have the ownership and flexibility of configuring minimum and maximum thresholds, customizing scale configurations for server build profiles such as instance type or VM size or regions, managing change effortlessly from the developer's portal or by way of the RESTful API, and finally by monitoring scaling metrics in server and usage charts. There are 4 methods to configuring scaling of game servers. There's a default method, schedule method, dynamic method, and the event method. Each method has a unique approach to adjusting scale levels. You probably came across the default method in session 1, where PlayFab scales up to the max servers configured and scales down on sessions completed. In this mechanism, there's no additional steps required by you. It's the most simplest method, where you set a max and standby server limit, and PlayFab automatically shrinks and grows VMs by way of player demand. But you may be facing scenarios requiring you to scale your servers due to a planned launch. That's where scheduled standby comes into play by increasing the size of the standby pools at a scheduled date and time within a one-time or recurring occurrence. You may need to scale your servers due to an unpredictable spike in player demand. That's where dynamic standby comes into play by increasing the size of the standby pool as it gets depleted, which allows you to react to sudden spikes in demand without always maintaining a giant and costly standby pool. Lastly, you may need to scale your servers to specific limits in response to a custom event generated by your custom game server code. In all circumstances, you provide planned configuration instructions to either when or at what rate the standby levels are to be sized. The interesting thing about scaling game servers is that scaling is something you think about after your game is running. With that notion, Dimitris is going to take you through a quick demo of scaling your game server allocations from within the Game Manager Developer Portal. The demo continues from session 1 of this GameStack Live presentation. No further downloads are required, and you'll be able to use the running game server built from session 1. But before we start, however, Dimitri will walk you through 4 key concepts that must be understood about game server scaling with PlayFab. Dimitris?
Thank you, Lester. We're going to describe some key concepts regarding scaling. Right? First and foremost, the scaling mechanism controls the number of standing by server availability. Right? So when we say about scaling, we always mean how to modify the number of requested standing by from our platform. If you recall from my previous presentation, standing by servers, they are servers that have been already created on the virtual machine, but they have 0 connected players. Basically, this is the state of your game server that full initialization has taken place, and your game server is ready to accept players in response to a request multiplayer server API call. This call will essentially modify your server from a standing by state to active state, where players can go there and enjoy your great game. However, one thing to remember is that your service will transition to a terminating state when the game server process exits. Last but not least, the scaling mechanism applying to standing by availability, they are uniquely applied on every region of a build. If you recall from our previous presentation, when we create a new build, we specify the build regions. Each scaling mechanism can be applied at a single region, and this is represented as a region override. The first scaling option we're going to describe is schedule. Right? Schedule basically means that you want to modify your standing by number based on a schedule. For example, if you notice that your game has more players connected to it on the weekend, you can have a repeated pattern where every weekend your standing by count grows. Another example is if you are going to launch your season 2 of your game next week, and you don't want to be there to modify the standing by before the launch, you can do it today. You go to developer portal, you select the date, and you select the standing by availability for this date. Time for a demo. In order to modify the schedule standby settings for our game, we need to log into the developer portal, select multiplayer, then select our build. And if you recall, we mentioned that region overrides basically are what we're going to use to modify our schedule standby. So this build has a target standby of 2. So we're going to edit the overrides for West US, and we're going to add a new schedule override. We'll use the example that we have more players, more traffic every weekend. So we can call it weekend traffic increase. We're going to modify the standby from 2 to 15, for example, and we want it to start May 7th, every Friday, and it will last for 3 days. Just repeat weekly. Save, done. Only a matter of clicks, and our schedule standby settings for increased standing by every weekend are applied. The next scenario we're going to describe is dynamic scaling, right? So dynamic scaling allows us to follow the demand curve from player traffic, reducing the need to manually provision multiplayer server capacity in advance. Just to give you a simple example, basically what our platform does is monitoring the standing by availability levels, and when they drop below a certain percent, we can increase it. For example, one simple scenario, you can say that when your standing by availability drops below 50%, then increase the standing by 25%. When it drops below 25% of availability, increase it by 200%. So it's a very easy way to configure your build to increase in standing by levels without having at all times to maintain a big standing by pool. Let me show you a quick demo of that. In order to modify settings for the dynamic standby, we again have to log in into the developer portal, select the multiplayer page, select our build, and go back to edit the override for the region that we want. So there is a button here, dynamic standby off. We're pressing it, goes to on. And the most important setting that we need to configure are the standby thresholds, right? So here are some default values that the platform has already set. So for example, this means that when our standby drops below 50%, our standby number will be multiplied by 1.5. When it drops below 25, it will multiply by 3, and below 5, it will be multiplied by 4, right? Those levels are recommended by the platform. You are free to modify them. You are free to use them as you want. In order to save it, you just press save and close. Done. And you see here very good, great visual indicators that this region has schedule overrides and dynamic standby enabled. It's so easy to configure dynamic standby on the platform. For the last scenario, Lester will describe how event triggering works in order to modify the standby levels. Lester?
Thank you, Dimitris. Triggering scaling limit changes as a result of an event is a common scenario for successful games that need to resize their scaling limits to an outcome unique to game server logic. Here are two examples where this is most applicable. A special gaming event that hosts a celebrity may drive an unpredictable spike in player demand. Now, while dynamic standby, which was discussed by Dimitris, is a likely scaling method to mitigate spikes in demand, you may want to monitor the presence of a unique player or collection of players and trigger scaling limit changes based on the event generated when these players log on. Another scenario would be a complex path, level, or map in your game server code. If a larger than expected number of players traverse these routes that generate greater demand on VM resources, you can also adjust the scale levels on the trigger of a custom event generated from an increase in specific server performance metrics. A custom event can be bound to a game server metric like CPU utilization, memory consumption, servers per VM, sessions per server, or players per server. Adjusting the scale levels from a custom event is pretty straightforward, but it requires a methodical number of steps to proceed. They are setting up a custom event, setting up a cloud script, setting up an automation rule, triggering the event which activates the automation rule and executes the cloud script, and 5, monitoring the incoming custom event and scale level changes in your game server build. Now, steps 1, 2, 3, and 5 can all be accomplished in the Game Manager developer portal. Step 4, however, will be implemented in your custom game server logic. For testing, you can also use the REST API client like Insomnia, Newman, or even Postman. In this session, we'll use a REST API client to simplify the event creation and call. Also, this session will target a game server build whose max and standby server limits are both configured to the values of 0. In step 1, we'll set up the custom event that will trigger a cloud script. Now, PlayFab records a lot of events automatically, like a player login or logout, and multiplayer server events that reflect on server state changes between active and standby, as well as scaling value changes. In this demo, we'll need to create a custom event that is very specific for your game. The idea of custom events are that developers are to generate and post events with an arbitrary type and name. Similar to PlayFab's automatic events, custom events are fully reflected throughout PlayFab's real-time analytics tools. But unlike automatic events, however, you need a little bit of custom code to post custom events. In step 2, we'll set up the cloud script to call the update build region API to adjust scaling levels of a build in a game server build in a specific region. Cloud scripts are server-side code written in JavaScript and hosted by PlayFab for free. You will access the cloud script in Game Manager by selecting automation from the sidebar navigation, then choosing the Cloud Script menu option in the Game Manager. The script essentially retrieves the main body properties of the custom event and passes them as values to the Update Build Region API. The Update Build Region API updates a multiplayer server build's region configuration, such as scaling limits for max servers and standby servers. This API also enables you to programmatically enable and configure settings for dynamic standby and schedule standby previously demonstrated by Dimitri as well. PlayFab's online documentation includes a rich collection of tutorials for writing custom cloud script and interacting with PlayStream events. Remember that the format of the required properties of the Update Build Region API are fully documented in PlayFab's online documentation. In step 3, we'll set up an automation rule to react to the custom event in real time. A rule consists of exactly one trigger, an optional list of conditions, and typically at least one action. In this demonstration, the trigger is the custom event from step 1, and the action is the execution of the cloud script from step 2. You will access the rules in Game Manager by selecting Automation from the sidebar navigation, then choosing Rules from the menu option. For the rule to find your custom event made in step 1, provide an event type using the canonical name of the event, that being event namespace.eventName. In this demo, the namespace was title.52bb5, and the event name is MPS event. Finally, specify the cloud script function name declared in step 2, where you author the cloud script. It's a good idea to enable the checkbox Publish Result as PlayStream Event to help monitor the event processing in the PlayStream monitor, as well as assist with diagnostics in the case there are any issues. In step 4, we'll trigger the event we set up in step 1 using Postman. Triggering the event is intended to activate the automation rule, which executes the cloud script. Observe the response body of your custom event includes an event ID, another useful diagnostic property to help with troubleshooting if required. You may trigger your event in your custom game server logic based on a condition that requires your game servers to scale up or down. In this session, I'll use Postman because it's one of the fastest ways to test this scenario without a fully coded client or service. The Postman collection provides JSON mapping to the complete PlayFab API. Every API method is set up with variables and URLs and parameters, making it easy for you to test quickly. Finally, in step 5, we'll monitor the incoming custom event and changes to the scaling limits. The easiest way to see the event pipeline in action is through the PlayStream monitor. The PlayStream monitor is a real-time stream of all the events for your game, including the custom events we fired in the previous step. You can access the PlayStream monitor in Game Manager by selecting the title overview from the sidebar navigation, then choosing the PlayStream monitor menu option. The events reported include delivery of the custom event, the rule being activated, the cloud script being executed, and the build region being updated. Lastly, to observe the scale level changes in your game server build, return to the build server summary page and refresh it to see the updated values. Observe that the max servers and standby levels have been adjusted to the specific settings provided in the custom event configuration of step number 1. In this session, the max and standby server levels were originally configured to 0, but after the custom event was triggered, the max and standby server levels were increased to 4 and 2 respectively. We've walked through 5 steps to send an event that triggers a cloud script which calls a multiplayer server API call to scale max and standby server limits. Demetrius and I will now demo the delivery of this event and monitor its arrival in the PlayStream monitor. The event will modify game server's build max and standby limits to the values of 4 and 2 respectively. That's 4 for max servers and 2 for standby. In this demo, the build summary page illustrates what the current max and standby server values are. They're currently set to 0. Demetrius, will you please show the PlayStream monitor?
Yeah. Here we are, Lester. Can you send me a couple of custom events for both regions?
Excellent. I'm going to send you a player event right now for the region East US, where the value for max servers is 4 and the standby is 2. Event number 1 delivered.
Event is here. Yes. Can you do the same for North Europe, please?
Event delivered.
Thank you. We see here in the logs that the cloud script has been called. So if we go to the build and we go to the build region configuration, we'll see that standbys can be configured to 2 and maximum can be configured to 4. Great work, Lester. Back to you.
Demetrius and I presented multiple server scaling methods. Our goal was to help new users to multiplayer servers configure server scaling limits with scheduled standby and dynamic standby, as well as generate custom events to trigger automation rules that adjust scaling limits. All the methods demonstrated in this session can be implemented quickly in the Game Manager developer portal. They're also accessible from the Multiplayer Servers API as well. What's next? If you currently have a game server built in PlayFab, you may want to use these methods now to reduce your standby server levels in test environments or low player traffic time periods to reduce server cost of your standby pools. Now be sure to explore the multiplayer API reference docs to programmatically adjust standby levels dependent on specific events or conditions in your game server code. The documentation also includes a very rich suite of quick starts and tutorials to assist with the steps illustrated in the advanced event-triggered scaling scenarios. If you have further questions, please post them on our Slack and community forums. Until then, thank you for listening to the GameStack Live session.
Thank you, everyone. Goodbye.